Alright, here are solutions for our chain rule worksheet from class today. The basic idea is I give you 13 functions that vary in difficulty. Some of them get pretty ridiculous as we get towards the end here. I'm going to ask you to find the derivative of each one. And to do that, what you'll have to use is the chain rule, often nested chain rules, often other rules as well. And I think really the biggest challenge of these problems is figuring out which rules you're using and where. So to that end, I try to color code these a little bit. Sort of the idea is with the chain rule, you have nested functions. You have a function inside of a function, possibly inside another function. So that's what I was going for with the colors. So for example, in this first one, instead of the square root of 2x cubed, you can view it as 2x cubed raised up to the 1/2 power. And if you write it like this, you can kind of see that you have this function in red here, 2x cubed, nested inside this other function, x to the 1/2 power, or maybe something to the 1/2 power. I don't know how you want to say that. So when you're taking the derivative, what you do with the chain rule, there's a formula for the chain rule. It tells you that the derivative of a composition of two functions, f of g of x, is f prime of g of x times g prime of x. Essentially what that's saying is take the derivative of the outer function, the f function, the outer in your composition, leaving the inner one completely alone, and then multiply that by the derivative of the inner one. Really, an easier way to think about this is you're kind of peeling off layers. So what I'm first going to do here is recognize that the outermost layer is in blue. It's something to the 1/2 power. And the derivative of something to the 1/2 power, well, I remember using the power rule. Maybe I should do this in blue. I bring that 1/2 down in front. I subtract 1 from the exponent to get negative 1/2. You're used to there being an x in here, in which case you'd be done. But in this case, there's not. There's a function in there, 2x cubed. We're going to start by leaving that function alone, 2x cubed. Don't change it at all. Don't take the derivative at this step. A common mistake would be to write 6x squared right here. You don't want to do that. Leave this alone because it's f prime of g of x, not f prime of g prime of x. In other words, we compose the derivative of the outer function with the inner function left alone. Leave this alone. But then you're not done. You have to multiply that by the derivative of the inner function. So the red layer I'm just getting to now, I'm going to take that derivative and write it out here. This right here would be our final answer. You could rewrite this if you were the type that liked rewriting things. You could say this is, 6x divided by 2 square root of 2x cubed, something like that. You could even cancel these out and say that this is 3x over the square root of 2x cubed. Lots of different ways you can rewrite this, but I'm not even going to bother actually. I'm going to erase those, because I kind of like the answer left like this. I think if you leave it like this, it's easier for the reader to follow to see where all the different pieces came from. Yeah, if you were to use this for something, if this wasn't the ending point, if you were going to take another derivative or something, you might want to simplify it. But for our purposes, I'm going to leave the answers looking like this. All right, let's continue. Maybe I'll go a little bit faster through these. So now I'm taking the derivative of a composite of 3 functions. The outermost function is 2 to the x, 2 raised up to some stuff. If it were just 2 to the x, the derivative would be 2 to the x times the natural log of 2. But it's not. Instead of an x up here, I got all this stuff, something raised up to the 1/2 power, x e to the x raised up to the 1/2 power. So I've taken the derivative of the blue layer. My next layer is the red layer. So I'm going to peel off the red one layer at a time. The derivative of something raised up to the 1/2 power. Well, I'm used to x to the 1/2 power being 1/2 x to the negative 1/2. But I don't have x to the 1/2 power. I got x e to the x to the negative 1/2 power when I take the derivative. So what I've done here is taken the derivative of the blue. Here I've taken the derivative of the red. Now I want to take the derivative of the green. The derivative of x e to the x. It ends up being e to the x plus x e to the x. Maybe I'll just note that this is the product rule. Something times something else, f, g. F prime is 1, g prime is e to the x. You end up with this right here. Again, lots of different ways you can rewrite this. You can collect like terms. You can probably cancel stuff out. I'm not going to bother. I'm going to leave this looking just like this. Okay, moving on. For this problem, as you see, you got something multiplied by something else. So it's going to be the product rule. Maybe I'll detail it a little bit more in this case, because it's a little bit more complicated than above. Product rule tells you that the derivative of f times g is f prime g plus g prime f. The derivative of a product of two things I know if I could just figure out the derivatives of those two things individually. So the two things I'm multiplying together in this example are the sine of x squared and e raised up to the 2x squared power. So when I write f prime right here, what I mean is I want the derivative of this thing. If I could figure out f prime and g prime, I'd have all the information necessary to apply the product rule and get my final answer here. The problem is figuring out f prime and g prime are a bit of a challenge. To figure out f prime, to figure out the derivative of this guy, pretend you're starting out right here. It's a brand new problem. To figure out that derivative, you got to use the chain rule, because you got a function in red here nested inside another function in blue. If this were just x squared, the derivative, well, this should be blue, would be 2x, but it's not x squared, it's sine of x squared, so the derivative is 2 times sine of x. But then you're not done, you still have to multiply by the derivative of sine of x. We've taken the derivative of the blue, now I need to take the derivative of the red. The derivative of sine is cosine, so I get f prime is 2 times sine of x times cosine of x. What about g prime? Well, if it were just e to the x, the derivative would just be e to the x. But it's not, it's e to the 2x squared, so the derivative of the blue part is e, and then leave this alone, but then you're not done, you have to multiply that by the derivative of the red part. The derivative of 2x squared is 4x, so you get e to the 2x squared times 4x. And now that you have all these pieces, you can get your final answer. Maybe I need to show where this stuff is coming from. Using the product rule, I know that the derivative of f times g is f prime, so that's 2 sine of x cosine of x, times g, which is e to the 2x squared, plus g prime, e to the 2x squared times 4x, times f, which is sine of x squared, aka sine squared of x. This right here will be my final answer. Okay, moving on. Here we have, I think, 4 different nested functions, 4 different layers. Following the notation I've been using, the outermost layer is in blue. So I have a bunch of stuff being squared. Note that 3 and 4 look very similar. 3 is a product rule, but yeah, there's some chain rule in there. 4 is just chain rule. This is not sine squared times this stuff, it's sine squared of this stuff. There's no x right here, so it's sine squared of a bunch of stuff, which is why I have these 4 different layers. So outermost layer, something raised up to the second power. If it were just x squared, the derivative would be 2 times x. It's not just x squared, it's the sine of e raised up to the 2x squared power squared. So when I take the derivative, bring the 2 down in front, and I make the new exponent a 1, and now I've taken care of the blue layer. But then I'm not done, I have to multiply that by the derivative of the inside. So everything that's written up here, except for the blue. So to do that one, notice I have another layer of sine of some stuff. The derivative of sine of x is just cosine of x, but I'm not being asked the derivative of sine of x, I'm being asked the derivative of sine of e to the 2x squared. So that derivative is cosine of all that stuff, but then you're not done, you have to multiply that by the derivative of all this stuff. So I've taken care of the blue layer and the red layer, I'm to the green layer. I got e to the 2x squared. Well, for just e to the x, the derivative would be e to the x. It's not, it's e to the 2x squared, so the derivative is e to the 2x squared times the derivative of 2x squared, which is 4x. You end up with this entire mess as your answer. Again, you can rewrite it if you really feel like it. Like, I mean, one thing that jumps out to me is that's 8x, but I wouldn't bother. Leave it just like that. All right, down here, I got a product rule again. Guess I'll do blue. How do I know I have product rule? Because I see something times something else. The first somethings, which I denote with the letter F, is e to the 2x power. The second of those somethings, which I denote G, is 2 to the 2x power. If I could just figure out f prime and g prime, I'd be done with this problem. Essentially, I just have to put the pieces back together using the product rule. It's relatively easy when you get to this stage in the class. So really the challenge is figuring out what is f prime and what is g prime. What's the derivative of this? What's the derivative of this? Kind of working down into a wormhole and making the problems easier and easier. Think we're just starting right here, e to the 2x. What's the derivative of e to the 2x? Well, if it were just e to the x, the derivative would be e to the x. Taking the derivative of the blue part is done in this stage, but then I'm not done. I have to multiply that by the derivative of the red part. The derivative of 2x is just 2. While g prime, well, it's similar, except now my outer function is 2 raised up to this stuff. If it were just 2 to the x, it would be 2 to the x times the natural log of 2 would be the derivative. But it's not just 2 to the x, it's 2 to the 2x. So the derivative is 2 to the 2x times natural log of 2 times the derivative of 2x, another 2 here. Note this is not natural log of 4. This is natural log of 2 times 2. I got f, g, f prime, g prime. Throw them all together using the product rule. Call this one good. So f prime, maybe I'll write it down here, is 2e to the 2x. That's what I have written here. Times g, which is 2 to the 2x, plus g prime, which is 2 times 2 to the 2x natural log of 2, times f, which is e to the 2x. Get this right here as your final answer. Could clean this up a little bit. You can't say 2 times 2 is 4, but you could say this is 2 to the 1 power times 2 to the 2x power, which is 2 raised up to the 2x plus 1 power. You could then combine, well, there's stuff you can do, but I'm not going to bother. I'm going to leave it just like this. Okay, again, 4 different layers of functions. So you see blue, red, green, and purple. The outermost is the blue. So you first take the derivative of the blue. The derivative of sine is cosine, so I get cosine of a bunch of stuff. I'm going to be lazy. Sine of cosine of cosine of x. But then you're not done. You have to multiply that by the derivative of the red. Derivative of sine of stuff would be cosine of stuff. Cosine of cosine of x. 1, 2. Then you're still not done. You've taken care of the blue and the red. Now you got to take care of the green. Derivative of cosine is negative sine. Sure. Times negative sine of cosine of x. Still not done. You have to multiply by the derivative of the purple stuff. Derivative of cosine of x is negative sine of x. Get something like this. Negative and a negative, you cancel those out. Yeah, go ahead if you feel like it. You don't have to. Product of 4 things. Really, instead of this all being in blue, it should have been blue, red, green, purple to follow the notation I've been using. But I think this is good enough that people can tell what's going on, so I'll call that good. Derivative of secant of x tangent of x. This one's a little bit tricky, or a little bit hard to see what's going on. But we'll approach it the same way. We got a chain rule. We got a function, secant of x times tangent of x, inside another function, secant of x. So I'll take the derivative of the blue part first. I'll note if it were just the secant of x, the derivative of secant of x in blue I'm looking at here, not to be confused with this one. The derivative of secant of x is secant of x times tangent of x. So the derivative of secant of some other thing is secant of something times tangent of something. That's something being what I have in red here. Secant of x times tangent of x. But then you're not done. This is just taking care of the derivative of the blue. We have to multiply that by the derivative of the red. The derivative of secant of x times tangent of x, that's a product rule. It's something times something. So using the product rule on the red part, I get the derivative of secant is secant of x times tangent of x, and then leave this tangent of x alone. So this is f prime, this is g, and then to that I want to add g prime, so the derivative of tangent, which happens to be secant squared of x, times f. F is secant of x. So f prime g plus, this is g prime, and this is f. Add them together. This right here is your final answer. Maybe I need a box around that to tell what the hell's going on. All right, number 8, tangent of secant squared of x. You want to think about it like this. You have an outer function tangent. The derivative of tangent is secant squared. So in blue, I'm going to write secant squared something. And what is that something? Well, in this case, it's something being squared, specifically secant of x. So in this stage, I've taken care of the blue stuff. What I now have to do is the red stuff. Something being squared, well, the derivative of x squared is 2x. The derivative of something squared will be 2 times something. But then you have to multiply by the derivative of that something, right? I've taken the derivative of the blue, derivative of the red, finally the derivative of the green. The derivative of secant is secant of x times tangent of x. So you end up with this message, your answer. Probably rewrite that, make it a little bit prettier. I ain't gonna bother. This problem is more tricky than anything. You probably feel like you get it right and you're close to right, but you're putting down something that's technically not quite right. And really the issue is the parentheses. So really, I want you to recognize that the outermost function is something raised up to the 1/2 power. That's not blue. Just take the derivative of something raised up to the 1/2 power, you bring the 1/2 down in front, change the new exponent to -1/2. If it were just an x, I'd be done at this stage, but it's not an x, it's a bunch of stuff. So I leave all that stuff alone. And then I multiply this times the derivative of that stuff. So I've taken care of the blue layer. My next layer is the stuff in red. And this is where things start to get a little bit confusing. So the stuff in red, if the blue is gone, is a sum of 2 things. All right, 4x plus all this stuff. The derivative of 4x is just 4. The derivative of all this stuff is going to involve chain rule. So I'm going to get something times something times something else. When I get down to this purple, there'll be a 2 at the very end. It's going to be a lot of stuff being multiplied together. However, that stuff should not hit this 4, because the derivative of 4x is just 4, not 4 times anything else. So I have to be really careful not to close a red parentheses right here, which is what you're tempted to do, and instead close it at the very end of the entire problem, way the hell out here. The rest of the stuff in red is something raised up to the 1/2 power. So I make that 1/2. I make this -1/2. If it were just x, I'd be done, but it's not. It's 3x plus something to the 1/2 power. That something being 2x. Note that I'm going to multiply this by something. I'm going to keep going, right? I've taken the blue and the red. What I now got to do is the green. And when I'm taking the derivative of the green, I'm going to continue this product, so it's going to be times something else. However, what I write here is only going to get multiplied by all this stuff. It's not going to get multiplied by the 4, and that's key. That's what I wanted to have happen. If I put another closed parentheses here, I'd be getting a slightly wrong answer. Derivative of the stuff in the green, just like we did in the red, derivative of a sum, 3x plus this thing, is the sum of the derivatives. The derivative of 3x is just 3. The derivative of this thing is 1/2 something to the -1/2. It's tempting to close the green parentheses here, but you don't want to. You want to close them at the very end of the entire problem, because I don't want any residual chain rule stuff from this term to get multiplied by this 3 right here. I'll leave the 2x, my final layer, alone here, and then in the next step I'll multiply by the derivative of 2x, which is just 2. Parentheses didn't quite end up where I wanted them, so I'll rewrite them here, cross these out, and call this good. All right, moving on, number 10, almost there. Okay, the derivative of, note in blue I have a sum of 2 things. The derivative of a sum is just the sum of the derivatives, so I got to take the derivative of this thing, and then add to that the derivative of this thing. Derivative of this thing is just 0, that's easy. 2 is just a constant, that stays alone, that's this 2. Times the derivative of e raised up to some power is e raised up to that power, 2x squared plus 2 to the 2x plus 2. Maybe plus 0 if you want for this right here. Well, that's not true. The plus 0 would be at the end. And anyways, there is no plus 0. You don't have to write plus 0. We're not done. We've just taken the derivative of the blue. We want to now take the derivative of the stuff in red. So if you stare at this thing in red right here, its derivative is going to go down here. So I want to multiply that by, well, let's see, the derivative of 2x squared is 4x. The derivative of 2 raised up to a power, well, if it were 2 to the x, the derivative would be 2 to the x times natural log of 2. But it's not. It's 2 to the 2x. So the derivative is 2 to the 2x times natural log of 2 times the derivative of the 2x, which is 2. Confusing? And then plus 2, the derivative there is plus 0. So the derivative of this 2 all by itself is 0. So you know what? I'm going to write it. You don't need to write this plus 0 right here, but my hope is that it helps people see where all the different pieces came from. Something like that. Blue and red, these two zeros right here. Of course, you don't need either of those. And that's what we get for our final answer. Last page, 3 more problems. Number 11. You're given this huge mess, but note that the square root of the whole thing is just raising it to the 1/2 power, and then 1 divided by the cubed root of something is something to the negative 1/3 power. And when you have something to the negative, when you have something raised up to an exponent raised up to another exponent, you just multiply those two exponents. Negative 1/3 times 1/2 is negative 1/6. So really the question is asking for this thing, which we can color code like this and notice just one chain rule. As long as you can get down to here, this problem's relatively easy. If you try to just attack it, quotient rules, it can be really messy. So the point here was to simplify first, it'll make your life easy. When you're taking the derivative, easier anyways. When you're taking the derivative, if this were just x to the negative 1/6, you bring the negative 1/6 down in front, subtract 1 from negative 1/6 to get negative 7/6, and you'd be done. However, you're not done because it's not just x raised up to that power, it's this thing raised up to this power. So what you do is you leave it alone in this step, and then you multiply it by the derivative of this thing. The derivative of x cubed is 3x squared, the derivative of x squared is 2x. You get this mess here is your answer. What about this guy? Well, I got a quotient rule. I got something up top. So first of all, note 2 to the x times 3 to the x is 6 to the x. It's a helpful little fact. It makes this problem easier. It makes it so you don't have the product rule down on the bottom. But if you get to here, we can use the quotient rule. And we got f is the thing up top, which in this case is 2 raised up to some power. That power being 3 to the x. I don't need another color here. Okay, and the thing down on the bottom, g, is 6 to the x. So if I could just figure out f prime and g prime, I'd be done. I just have to put the pieces back together using the quotient rule. If it were just 2 to the x here, the derivative would be 2 to the x times the natural log of 2. But it's not. It's 2 raised up to this weird power, the 3 to the x. So I leave the 3 to the x alone here, and here I multiply by the derivative of 3 to the x, which is 3 to the x natural log of 3. Didn't quite fit. Three to the x times the natural log of 3. That goes right here. And to figure out g prime is sort of the same idea. The derivative of 6 to the x is just 6 to the x times the natural log of 6. So if I put all these pieces back together using the quotient rule, I got f prime, which is 2 raised up to the 3 to the x power, times the natural log of 2, times 3 to the x, times the natural log of 3. This is all f prime. I want to multiply that by g, which is 6 to the x. From that, I want to subtract g prime, 6 to the x natural log of 6, times f, 2 raised up to the 3x. And I want to divide that entire mess by g, 6 to the x, squared. You can clean this up a whole bunch if you want to. I don't want to, so this is my final answer. Okay, this mess of a problem. We got several quotient rules, several nested chain rules, and I'll do my best to talk you through them. So basic idea here is the first thing I want you to recognize is that I got the parentheses wrong. There should be another set of parentheses. I want the derivative of this entire thing. But that's not really all that important. The outermost layer that I'm taking the derivative of is all this stuff raised up to the 10th power. If it were just x to the 10th power, I would say, well, that's 10 times x to the 9th power. But it's not. I guess I should copy it all again. It's not just x to the 10th power, it's all sorts of stuff to the 10th power. So I got all that stuff raised up to the 9th power with a 10 out in front of it. So I'm going to recopy everything here in green, red, and purple over here, just so my final answer is complete. 10x to the 10th plus 10 e to the x divided by x times 10 to the x. So that mess, and that mess is raised up to the 1/10th power. And that gets divided by some other fraction raised up to the 10th power, that other fraction being 10 minus 10x divided by 10 to the 10x plus 10 minus 10. What I've done in this first step is I've taken care of the blue up here. My next step is the first step where this is going to get really messy, is take care of the red, this second layer of functions here. And what I want you to notice when you look at the red is that it's something, this thing up top, divided by something else. So I got a quotient rule. So for my red step here, what I'm going to get, yeah, that'll work. Go all the way to the end here, is a quotient rule. And so what the quotient rule tells you is that the derivative of f divided by g is f prime, which I'm eventually going to write right here, times g, the thing on the bottom, which is this guy right here, 10 minus 10x divided by 10 to the 10x plus 10 minus 10. It's f prime g minus g prime, which is going to be a mess, times f. F being the thing up top, 10x to the 10th plus 10 e to the x divided by, see, the thing up top is all raised up to the 1/10th power. I forgot about that. And the thing on the bottom is f prime g. Sorry, this is the, jeez, if I can't do it, I shouldn't be asking you to do it. Thing on the bottom, f prime g minus g prime f. So this is g right here. It's the thing that's written on the bottom. This is f, the thing that's up top. The thing up top is 10x to the 10th plus 10 e to the x divided by x times 10 raised up to the x power, all to the 1/10th power. F prime g minus g prime f divided by g, the thing on the bottom, 10 minus 10x divided by 10 to the 10x plus 10 minus 10 squared. F prime g minus g prime f. All I got to do is fill in the f prime and the g prime. All I got to do. It's going to be a huge mess. So here, what I'm going to write in these parentheses right here will be f prime. It'll be the derivative of the thing that's up in the top here. Well, if I'm just looking at the thing that's up in the top here in red, what I'm going to do is I'm going to notice it's stuff to the 1/10th power. So let's bring the 1/10th down in front and make the new exponent negative 9/10, and then leave all of this as it is, 10x to the 10th plus 10 e to the x divided by x times 10x. So I'm still working up here. I'm trying to figure out f prime, the derivative of this top part here. And I've taken care of the red. I still got to do the green. The problem with the green is it's a quotient rule. So the derivative of just the green up top here will be f prime, the derivative of the top. So maybe I need to set up a quotient rule here. My quotient rule eventually is going to go here, and it'll be something divided by something. F prime is going to be 100 x to the 9th plus 10 e to the x. That's the derivative of the top here, times g. G is the bottom, x times 10 raised up to the x, minus g prime, the derivative of the bottom. Well, the derivative of the bottom is a product rule. Derivative of x is just 1. So I get 10 to the x plus x, well, plus 10 to the x natural log of 10. Shoot, out of room. Try again. All right, what I'm doing down here is I'm trying to figure out the quotient rule. I'm trying to figure out the derivative of the top right here. The derivative of the top of this fraction. The top of this fraction is itself a quotient rule. And so it's got something divided by something. F prime, the derivative of this, is what I wrote here. G, the bottom, is what I wrote right here. Minus G prime, the derivative of the bottom, which is what I'm trying to figure out. To figure that out, I have to use the product rule. So the derivative of x is just 1, and you get 10 to the x, plus the derivative of 10 to the x is 10 to the x natural log of 10. But then you got to leave that x. This is the derivative of the bottom here. You have to multiply that by the top, which is 10x to the 10th plus 10 e to the x. F prime g minus g prime f, all divided by g, x times 10 to the x squared. This thing right here is what goes right there. Wow. Now I'm finally done with the derivative of the top in red here, the f prime. It's all this stuff. This is the bottom in red, the g, minus g prime. The last little bit I need is what goes right here. What goes right here will be the derivative of this thing on the bottom here in red. So the derivative that's going to go here, I'm not going to be able to squeeze it in because it's going to take up way too much room. Okay, so my last piece of the puzzle, what will end up going here, I'm going to try to squeeze it up here somewhere, is the derivative of the bottom here in red. To figure out the derivative, I got to use the chain rule. The outer function is stuff raised up to the 10th power. So I take that 10 and I bring it down in front, and then I got all this stuff raised up to the 9th power. The stuff in this case is 10 minus 10x divided by 10 raised up to the 10x plus 10 power minus 10. It's this. I've taken care of the red layer, now I got the green layer. To take the derivative of the green layer, I got a quotient rule. Derivative using the quotient rule would be f prime times g minus g prime times f divided by g squared. Okay, one step at a time. F prime, the derivative of the top here is negative 10. G, the bottom, is 10 raised up to the 10x plus 10 minus 10. F prime g. From that I want to subtract g prime, the derivative of the bottom. The bottom's the sum of two things. The derivative of this one is just 0, so I just need the derivative of this one. If it were just 10 to the x, my derivative would be 10 to the x times the natural log of 10. But it's not 10 to the x, it's 10 raised up to some weird power. That power in this case is 10x plus 10. So I get 10 to the 10x plus 10 times the natural log of 10 times the derivative of 10x plus 10, which is itself 10. Keeping all that straight? Probably not. F prime times g minus g prime times f, top being 10 minus 10x. That goes right here, which you can't even see anymore. Then down on the bottom, I got g, which is 10 to the 10x plus 10 minus 10 squared. This thing that goes from here over to here is what goes in here and completes the problem. This huge mess in blue and in red is my final answer. It's just I didn't have room to write this thing up here and this thing down here. That is a mess, and I'm happy to be done with this.